Hello, I am Zachary Karcher, and this is my 12 and 13 tutorial for GHS Electrical Engineering. This is a combination of tutorials 12, which is using a temperature sensor, and 13, which is driving a servo motor. In this modified tutorial, I will be using the temperature sensor, which looks similar to a transistor, yet we have ours marked with silver nail polish. It's made out of a semiconductive material that changes electrical properties consistently with the temperature, and the output of the center pin changes with it between the ranges of 0 and 1023, which can then through the Arduino microcontroller be converted to either Celsius or Fahrenheit using a formula I'll go over when we look at the code. I'll also be using a servo motor, which is different from a hobby motor I used in a previous tutorial. This motor, unlike a hobby motor, can only move from 0 to 180 degrees, no more. They contain a DC motor, a controller board, and a gearbox. It works by interpreting PWM, or pulse width modulation, which works by, instead of supplying a constant supply of electricity, it controls the signal by toggling the signal between high and low, which, for example, prevents LEDs from overheating. The servo motor will then rotate to a certain position based on the degrees at which the temperature sensor reads. And finally, we will be using a 4-digit 7-segment display to display the temperature readings of the temperature sensor. This one works with 12 pins, 4 which control the different digits, and 7 which control the different lines in the numbers. I'll be using 220 ohm resistors, which limit the flow of electrons in the circuit, a STEMterra board, which combines a solderless breadboard and an Arduino Uno R3 microcontroller, and as well, I will also be using an Arduino Mega because after plugging the display in, there wasn't any PWM pins left, so I needed the second board to run the servo motor using a PWM pin.
First, we will be looking at the working circuit. Here you can see the temperature sensor marked by the silver nail polish. You can see right there. The 4-digit 7-segment display, which is currently displaying 65 degrees, which is the temperature of my house. The STEMterra board. The servo motor. The Arduino Mega board. As you can see, it is, once I plug in the Mega, the servo will, it turned to 60 degrees from where it started, and it's currently doing that because, as you see, the temperature is fluctuating between 65 and 64-ish. Now, as you can see, if I hold this, you'll see the temperature starts going up to 72 because my body heat is running out. But if I were to put this ice to it, you could see the temperature starts to go back down. Yeah. And that is the working circuit. I did not use the serial monitor in this tutorial because whenever I used the serial monitor, it seemingly broke the 7-second display.
Next, we will be taking a look at the schematic for this tutorial. As you can see, we have all the schematic symbols I showed previously while explaining the parts I was using. Here we have the servo motor, which is attached to 5 volts, ground, and the digital input 9, which is PWM. And you can see over here at analog 0, we have a connection coming back to the signal off the temp sense, and that can also be traced back to this board's analog 0. All these wires are connected to the different inputs for the digital display, including the 4 resistors, which are on the 4-digit display things, and the things which control the A, B, C, D, E, F, and G segments of the actual digits themselves. And here's the temp sensor, which is connected straight to 3.3 volts and ground. Finally, we will be going over the code for this tutorial. The code I used is uploaded to both boards since they both serve around the same function. The only difference is that I comment out either the display stuff or the servo stuff, and I'll explain more when I get to this. To start, we need the library for the servo, which is this one, and we also need a library for the 7-segment display. This defines the servo in the 9-pin, and this initiates the 7-segment controller object. This is the constant imp for the temp pin, which will start with 0, and then we have the initial temp value, and then we have volts, temperature Celsius, and temperature Fahrenheit. In void setup, we have the number of digits, which pins the digits are plugged into, which pins the segments are. Those are those A, B, C, D, E, F, G lines I was talking about. And this tells you how many resistors it's using. So you could set it to 1 if you want to use 8 resistors. And then this tells it to begin and sets the brightness to 90. Now, I do not have a serial. I commented out the serial monitor because for some reason the 7-segment wouldn't work with the serial monitor on, so I just commented that out. And this is the input for the temperature sensor. And for the void loop, we just take the temperature value, which is just the analog read of the temp pin, and we convert it into voltage, reading the voltage into a value that we can convert to temp Fahrenheit. And I found these equations, and this equation converts volts into temperature. Now again, I commented out the serial print stuff because it messes with it. Down here, now on the code I upload to our Mega, I uncomment this so that it will actually write the servo thing. And when I uploaded it, and I comment this out, but for this version, which gets uploaded to the Spark STEM Terra board, I keep that commented out and this on. I also don't use a delay because that also seemingly messes with the 7-segment. So this just sets what it's gonna print, and this sets how many decimal places it should have, and then this just refreshes it constantly. And that is the code. And that is the end of my 12 and 13 tutorial for GHS Electrical Engineering 2025.